Good morning and once again welcome to my YouTube channel, Pearson and Excel International Math by Mr. Kamoto. And in this video, I want us to just explain example 1 of binomial expansion in P2, page 63. Having understood the fundamentals of the topic, the power behavior, and the coefficient behavior. So the first one is use Pascal's triangle to expand x plus 2y raised to power 3. Now this one is just straightforward because we need to look at term 1 and expand it with the highest power, that is x cubed. Then we add, of course, within this one there is term 2, 2y raised to power 0, but of course it's obviously 1, so it is very silently put there. So the second term is the first term reduces power by 1, so x squared, but now the second term increases index by 1, so and the behavior x to power 1, 2y to power 2, and finally x to power 0, 2y to power 3. So when you evaluate this one, it gives you something to do with x cubed plus 2x squared y plus 2 squared is 4, x is power 1 and y is squared, plus 2 cubed is 8, x is to power 0, which means 1, y cubed. At that point now, introducing the coefficient, don't forget, very important, introducing the coefficients, and we have, and this is now where the Pascal's triangle becomes very important and very critical. We can borrow the coefficients of when the power is 3. You can see this is when the power is 3. We have the coefficient 1, 3, 3, 1. The coefficients are 1, 3, 3, 1, and that is it. So we introduce 1 to the first term, becomes, so the final submission is going to be x plus 2y cubed is going to be 1 times x squared, which is x cubed, not squared but cubed. But the coefficient of the second term is 2, so 2 is going to be introduced in the second term. It's not 2 but 3. 3 times 2x squared y becomes 6x squared y, and the third coefficient is 3. 3 times 4 is 12xy squared, and the final coefficient is 1 times 8, which is 8y cubed. And that is like the whole thing. It's as easy, it is as simple as that. It is as easy as that. And I want us to just go to part B. Just go to part B and talk of 2x minus 5 raised to power 4. And I would want to first of all highlight the coefficients. Here the coefficients are, you may want to borrow from the previous triangle instead of drawing another one or coming up with another one. The coefficients here, when the power is 4, the coefficients 1, 4, 6, 4, 1, 1, 4, 6, 1, 4, 6, 4, 1. When the coefficient is, when the power is 4, 1, 4, 6, 4, 1. Those are the coefficients. So expanding this with coefficients in mind so that we can just finish it once and for all. So we have 2x raised to power 4, of course, times 1, plus 2x raised to power 4 multiplied by minus 5 raised to power 1, and the coefficient here is 4. Plus the coefficient in the third one is 6 multiplied by the first term 2x raised to power 3. This is 3, this is 3, because the power continues to reduce by 1. So this is 2, yes, that is 3, and this is 2, minus 5 now increases the power to 2. Plus the coefficient is 4, 2x raised to power 1 minus 5 raised to power 3. And finally, we get the very last term, which is the coefficient is 1, 2x raised to power 0 minus 5 raised to power 4. 2x raised to power 0 minus 5 raised to power 4. So we only need now to conclude and say 2 raised to power 4 is 16. This is 16x4, and that is the end of the story for that particular term. The other one is 2 cubed is 8. 8 times minus 5, because negative 5 raised to power 1 is negative 5. 8 times negative 5 is negative 40. Negative 40 times 4 is minus 160 x cubed, and that is the end of the story. The third term now, 2 squared is 4, minus 5 squared is 25. So 25 times 4, that is 100. 100 times 6, we get 600 x squared. We get now to the fourth term. Minus 5 cubed is negative 125. Negative 125 times 2 is negative 250. Negative 250 times 4 is negative 1000. So we have minus 1000 x. And finally, we have minus 5 times raised to power 4. Minus 5 raised to power 4 is 25. 125 times 5 is 625. And of course, 2x raised to power 0 is 1 times 1. So we end up having positive 625. And that is the end of the story for that particular one. So again, be on the lookout. Note how the Pascal's triangle is assisting us easily get the expansion of any function, binomial expansion. And you can see all we need to do is have the coefficients ready and introduce them after the powers. Now it reduces for the first term and increases for the second term to form n plus 1 terms. So that is it. Let's see what happens in example 2.